Thank you. Time to start. You know, it's not the size of the audience that matters. It is the fact that it's the right people that matters. So, welcome everyone. My name is Thomas. I'm going to talk about some properties that I think could be applied onto what I would like to call a responsible developer. So when I started out preparing this talk, I asked a friend, how would you describe a responsible developer? I'm not sure if he heard the word responsible, but he heard the word developer, and he thought, well, this is someone who takes coffee, pizza, and turns it into code. That's one way of viewing it. I'm not sure that is applicable. You could also ask yourself, is this some kind of superhero? To be honest, I don't think so. Is it a firefighter? Probably not. The firefighters, they're actually dangerous. They are probably the guys creating the fires at the same time. So the firefighters, be careful. Now, I would say that this is a specimen of a responsible developer. You probably don't know who this is. This is a guy called Alex. He lives in Bucharest, Romania, and he is really trying to be a responsible developer. He also happens to be a good friend of mine. He's quite an ordinary guy, nothing special, except the fact that he's very clever, but many people are clever. Quite ordinary, but with a passion for what he's doing. Passion, in this case, for programming and software development. And it is very much a matter of mindset. How do you think? What do you think is important? What do you think is not important? And it's also a matter of embracing change. Accept the fact that change happens. It's a part of our life. Everything changes all the time. If for nothing else, time passes. So we have to embrace that and be aware of it, that changes occur and handle them as good as possible. I once worked with a guy who claimed that it's utopia to be able to divide a problem. It's not. You can always divide a problem into something smaller, almost always at least. This guy, he didn't even try. Very complicated and very irresponsible. A responsible developer is probably someone who will do programming even if it isn't paid. At the same project, I had at least one colleague that didn't even consider writing code unless he got paid for it. Is that responsible? Not in my book, at least. How many in here has heard about the Agile Manifesto? 1, 2? Okay, so not too many. This is something some guys came up with 2001 after some discussions. And this is something that I would say you are aware of if you're a responsible developer. You're aware of the fact that it's more interesting to work with individuals than it is to have a process. Working software is the ultimate goal in some sense. It's a lot more interesting than have a book about how it might work, comprehensive documentation. Customer collaboration, that's much more interesting than negotiating with the customers. I have experienced project meetings where two project managers starting negotiating why we didn't have a test server. This was in May. This should have been delivered in February. We were supposed to deliver end of June. We didn't for some reasons. And responding to change instead of following a plan, very strict. So all the stuff to the left-hand side here is actually really important stuff, and this is something a responsible developer is aware of and does his best or her best to follow. The Agile Manifesto is almost only, no, not almost, but it's a lot about communication, talking to people. So a responsible developer will probably use the language of the customer. Try to speak and use the same words as they do. And this is where ubiquitous language comes into the picture in a sense. Something that comes from domain-driven design, and ubiquitous, that's, as far as I can tell at the moment, just a fancy word for common. Why didn't they choose common? I don't know. Maybe too easy. Anyhow, speaking the language of the customer, very, very important. There are some principles behind the Agile Manifesto. Few of them are, one of them is my absolute favorite, because this one, continuous attention to technical excellence and good design enhances agility. This gives me a free ticket of nerding in myself into a lot of technology. Technical excellence. That's great. And then this one is fantastic. Simplicity. The art of maximizing the amount of work not done is essential. So make sure we don't do stuff that is not needed. That's the responsible way to behave. Another thing that you should, or hopefully already is aware of, are the 4 rules of simple design, as Kent Beck proposed them in the book called Extreme Programming Embrace Change, 99, if I remember correctly. Test passes, very important. Means a couple of different things. It means that we have tests. How many in here is working with a code base that doesn't have any tests at all? How many in here like it? No one, okay. I work with at least one code base that doesn't have any tests at all. It's horrible. You're afraid of doing anything. So, test passes, extremely important. It is also very important that the code express intent. You actually are aware of what it's supposed to do. No duplication. Well, we all know that we should try to remove duplication if we see it. And the last rule, it should be small, whatever that happens to mean. Small, I mean, we could talk about the module, we could talk about the class, a method, doesn't really matter. It shouldn't be larger than it has to be, as small as possible. So if you follow these 4 rules of simple design, then you're able to create code that is hopefully easy to understand, easy to maintain. And that is the goal for a responsible developer. So how do you build a system? Well, there are a few different ways. Incremental, that is adding piece by piece by piece to something. Or, yeah, doing that would be very much like paint by number. Has anyone done that lately? No? No one has kids who does that? Yeah? You know what I mean? They like it. Could get quite nice. However, someone has to create this schema. And that's development. So paint by number. Nope, that's not how you build a system. You have a vision and then implement piece by piece. Perfect. Anyone ever tried to do that? Doesn't work. And that's not the way you want to do it. I can make the slides available if you're interested. Or I will make the slides available. It's a lot better to do it iterative. Build something and evaluate. Build a little bit more. Think, is this the right thing or is it not? Change it. And again. So building it this way, you envisioning a nice picture, you draw something not very nice from the beginning, you enhance it some more, and all of a sudden you have something really beautiful. That's the way to build systems. Not build the perfect database and then add the perfect model on top of it, and then don't have time to build a user interface. You don't want to do that. It's a lot better to divide and conquer if you can. Build small things and then some more. And this is, in a way, the way Unix are doing stuff. How many in here is working with Unix on a daily basis? A few. Okay, so you know what I mean. We're talking about solving one problem. Solving it in a very good way, and then combine the solution like this. So what does this one do? It will count the number of files that you find in a directory. And we have two commands here. We have ls, which lists files, and then we pipe result into word count -l that will return the number of lines found, which is the same as the number of files in that directory. But we have two different programs here, but they're pretty good at doing one thing at each. Combining them gives a solution. So small things that solve the problem in a good way, but not more. This means that we want to work with small tasks if we can, and therefore we get small solutions. And that is, in my point of view, the better way to future-proof any system. It's, yeah, how long time has Unix been around? Does anyone know? This chart will tell us. And let's see if we can zoom in on the year here. Oh, 1969. And you know, we still use it every day. How many in here was even born 1969? Oh shit. Okay, let's carry on. So it has been around for a long time. And it works. It still works. It is getting better and better, but it still works. So how to build a system then? Well, one way to do it would be to use a technique that's sometimes called a walking skeleton. That is, we create some kind of wireframe of our system. The important components are connected, but not much more. And then we enhance it step by step where we need it. So if we connect, say, the user interface with the database, it doesn't really do anything, and then add flesh where we happen to need it, then we would end up with something that might actually work. And we could also end up with something that works from the first day. It will not solve the entire problem, but it will work. And therefore we can ship it almost any time we want. So when the customer says, I'm bored, let's ship this, you can do that. So doing that and working in vertical slices is a great way. So imagine that we have a couple of customers like this. We build our system pretty much like a pipe. We connect everything we need all the way down to the database. Okay, nothing special here. But this is just a small part that we're building. But we're building everything we need. Then we add one more pipe, one more pipe, one more pipe. You know, we could continue here, but we could also ship now, because each pipe actually works. So if the customer is happy now, ship it. This is another way of looking at it. This is something that some people call a minimum viable product. Same idea. We want something that we can transport stuff with. So if we get a steering wheel, and only a steering wheel, we're not really happy. Doesn't do us any good. 2 wheels, no, not enough. Body part of a car, not enough. The entire car, yes, we're happy. But you know, if the problem I should solve could be solved with a skateboard, or for that matter a scooter, why not? So deliver a skateboard, the first thing you do. And then something better, a scooter, a bicycle, a motorbike, and all of a sudden maybe a car. But if the customer were happy with the skateboard, well, then you're done. I'm playing with an orchestra in Stockholm. We have this huge box, a crate, where we keep the bar. It's very heavy, lots of bottles. Sometimes we have to move it. A skateboard is enough. That's a minimum viable product in some cases. A responsible developer is also aware of the fact that a simple code is a lot better than smart code. Why? Well, I can understand simple code. I can maintain it. I can enhance it. Smart code, well, I can't talk for you, but I can talk for myself. I don't understand smart code. It's complicated. Too complicated often. So I want simple code, because that's easy to understand. So simple code on smart data is a lot better than smart code on simple data structures. So in some cases, a hash table would be the perfect solution. Some other cases, a linked list is the perfect solution. It all depends. Sharing and learning, that's also something that the responsible developer will do. And one way of sharing stuff, knowledge, is pair programming. How many in here are pair programming? Okay, so a few of you, that's good. The rest of you, you would like to try that because you learn so much. It's exhausting, but you learn a lot. So pair program is something that you would like to do. This leads to something that is called shared code ownership. If you pair program on something, you can't really say who is owning that piece of code or module or whatever it is. And why is that important? Well, if we have shared code ownership, then anyone is allowed to do changes. And since anyone has been working in a pair on that piece of code, they probably know what to do as well. So we don't have to wait for that specific person to do this fix, because that person is the only one who's allowed to touch this piece of code. No, we have shared the code ownership, and therefore we can fix the problem when they occur. So another thing that you do if you want to share and learn is mentoring other developers. Has anyone worked as a teacher? No? Oh, one, sorry. Oh, and over there. Okay, so a few of you. You who have worked as teachers, you know that you learn as long as you have students, because you must understand what you actually talk about before you can explain it. And therefore, teaching and mentoring is great. It's a great way to learn for yourself, and it's also a great way to bring someone up to speed. This means that you're constantly learning, and this is a win-win situation. You learn as long as you have students. The best job I've ever had was working as a teacher. It had other drawbacks, such as the pay was not that impressive, but the learning part of it and the feedback from students, that was great, at least for me. A responsible developer wants to know that it works. So how do you know that it works? Well, you can do that, as far as I know, in one way. You verify it. You check that it works. You test. So you are constantly testing. But that doesn't scale, so you have to write code that actually does the tests or check that it works. Checking is perhaps a lot better word than test in many cases. This leads to write the test code first, because then you actually know what you should implement. And this leads me to test-driven development. How many here are doing test-driven development then? Some, not all. Okay. But you know what I'm talking about? I hope so, at least. Then I'm kind of interested, although we don't have time to ask you why you don't do it at the moment, but I'm really interested because this is the absolute best way that I know of working and writing code. It is important that the test is the cleanest part of your code. Because if you can understand them, that means that you can understand what the system actually should do, even if it doesn't do it yet. But if you can't understand the test code, then you're pretty much screwed, actually. You really need that. Oslak Helsey, who is really good developer, he also happens to be father of something called Cucumber that I spoke about a little bit earlier. And if anyone is interested in Cucumber stickers, I have plenty of them. He claimed on a mailing list a couple of years ago that clarity always trumps dry. So when you're thinking, should I remove this duplication, or should I make this as clear as possible and allow some duplication, then you should allow duplication. Because then you can really understand what stuff is doing. And this is especially true when we talk about test code. If you have a good test coverage, then you have some kind of automated acceptance criteria. All of a sudden, you know that it works and you can ship it. And to get that, you want to work outside in. Because if you do that, if you work from the outside to the inside, then you will start out with the acceptance criteria, it doesn't work, and all of a sudden you implemented the system, probably using tests on the way. But then you have a set of acceptance tests as well, not just unit tests that allows you to do changes without being scared, which is very nice because then you know that you can ship it. It is also very important, as I hope that you know, but let's just repeat it. It's also very important that we don't test implementation details. Why is that important then? Well, if you test implementation details, then you will tie the test very, very closely to the production code. And that's maybe fine, but what happens when you change the production code? All of a sudden you have hundreds, or I don't know, lots of tests that breaks. And that could be the fact that you connected the tests too hard towards the production code, and you didn't really test the behavior, you tested the implementation. So testing the implementation details is stupid and therefore not something you should do. And if we work from the outside in, this allows us to focus on high level. We won't get lost among all the details. We will get lost among them anyway, but not yet. One way of doing this is to use scenarios like this. And if you saw my presentation earlier about Cucumber, you know that this is executable. If you didn't, you have to trust me. This is executable. And this is a way to express yourself in a way that other people can understand it easier. And it will all enable you to keep an eye on the overall picture. As I said, we will get lost among the details anyway, but with some luck we can postpone that a little bit. Clean code, one of my favorite subjects, and actually a subject that got me started speaking at conferences. I hope that you're aware of the fact that code is written once, but read very, very often. Therefore, you should make sure that it's really easy to read and understand it. Because we read and we maintain the code during a long, long, long time. So this is a piece of code that I borrowed, let's call it that. I'm contributing, the guy who wrote it, so it shouldn't be any problem. But this is a code I found on a blog that Jason Gorman wrote a while ago. What does this one do? Well, execute. No shit, Sherlock. Which method does not execute? Of course it executes. The worst name ever. Okay, so we have some kind of add, a negative and positive. To me, it looks kind of like we're moving from A1 to A2. That could be the case. But if you just saw the method header, then you couldn't tell that. You would have to look at the implementation to understand. And it could happen that the implementation were more complicated than this, therefore complicated. But this one is trivial to fix. If we mean transfer funds, well, call the method that, execute. Account 1 and account 2, well, someone is paying, someone is the payee, and someone is a payer. Someone will receive and someone will give money. So credit and debit. I run my own company. I try to do my bookkeeping myself. Credit and debit is magic because sometimes they work backwards depending on the type of the account. But that's not this discussion. Someone who knows economy would understand this directly. And if you implement working with an economy system, you would as well. So the best kind of code clearly tells the story of what the code does. And this is something that Jason Gorman published on a blog post. We can't see when, a while ago. Readability simplifies maintenance, so therefore it's very, very valuable. Anyone heard about Bob Martin, also known as Uncle Bob? No one? Okay. He wrote a book called Clean Code a while ago, long time ago now. He adopted something called the Boy Scout rule there. I've never been a scout myself, or I have been, but I don't really remember. When you're out camping, you're supposed to clean after you. And you're supposed to leave the campground in a better shape than you found it. So if we transfer this saying to code, that would say always leave the code in a better shape than you found it. Meaning that we will fix something. We won't fix everything. We might not have time for that, but something, such as the method name in the previous example. That's trivial. Especially if you have good tooling, then you can just change it. It might be affect many files, but that's a tiny change. You should be able to do that. And all of a sudden, the code got easy to read. So if we always do that, small things, then we will end up, if we do this infinite long time, we will end up with something that is good. Okay, we know that we don't have infinite time, but you get the point. That if we do this in small steps, then we could end up with something that is better. How do you do that then? Well, this leads me into refactoring. And the question, what does refactoring actually mean? Some people claim that it means improving the code, but I'm afraid it doesn't. That's not enough. It means improving the code while maintaining the functionality. A quote that I've borrowed from Adi Bulbuka, who happens to be brother to Alex, that you saw an image of. So improving the code while maintaining the functionality, important. And therefore, we don't really have a need for large rewrites if we do it in small steps, because we can do it. The rewrite can be done in many small steps. And since we have a lot of tests, they will save us when we do silly mistakes. If we don't have tests, then I wouldn't dare do refactoring, because then I would probably break something. I tend to do that. We're also interested in delivering value. And what is value? Well, that's what we want, whatever that happens to mean. But the only way I know that software can deliver value is when the customers are actually using it. Until then, it's just waste. So therefore, you want to deploy often. Why? Well, I just said that. Otherwise, we won't be able to give the customers any value. And even if we just give them prototype, it is worth at least 1,000 words. Because they can use it, and they can give us feedback and say that this wasn't really what we wanted. In order to do that, we have to build the system often, after each commit, obviously. And that leads me to continuous integration. And please tell me that you're using continuous integration. Yes. Not everyone, but most of you. That's good. But remember to keep the build green, no matter what. Otherwise, you might end up with a lot of problems. So you have to fix the builds immediately. You could end up with something like this. This building will be complicated, or it will take a long time to fix all the windows. But if you fix one window when it gets broken, then it won't be that complicated. So keeping the build green is very, very important. And therefore, stuff like commit and run, well, it's highly illegal. You do not commit and then go home. Then you commit tomorrow. Because you can be sure that you will probably break the build, and then the build will be broken until you come back, and that's bad. So commit and run, illegal, don't. Continuous integration. What do we want from the continuous integration then? Well, we want something that is deployable. So we want to deliver deployable artifacts from it. This means that code always must be in deployable state. This means the stuff that isn't fixed yet or finished yet has to be hidden. And one way of doing it is using feature switches. So you hide stuff that's not ready yet. The customer can't use it. It's almost, it's there, it's in the code base, but you can't use it, so therefore it's not dangerous. Deploying often, obviously. But when should you do it? Well, not on a Friday afternoon, because you will be in the office during the weekend then. Bad idea. Before lunch, yeah, take an early lunch. So you deploy early. Early in the week, Monday, Tuesday, good days. Wednesday, so-and-so, Thursday, maybe Friday, no. You don't deploy on a Friday, unless you have a system where you do continuous deployment, where you would deploy many times a day. But that's so unusual, so I didn't even consider that at the moment. But if you deploy often, means that you can only deploy small things, because you do it so often so you don't have time to build something large. So small things. Which is good, because it's scary to deploy large things. And I'm not a hero, and I'm not even brave. Maybe you are, I'm not. So deploying often, how do we do that then? Well, there's just one way of doing that, automated. And automating deployments are there are so many different ways you can do that, so I won't even go into it, but it has to be automated. If you do it manually, you won't be able to do it often. And this leads me to a quote a friend of mine delivered last August, I think it was. Yeah, last August. Laziness wins in the end. He said it in Swedish, so I have to translate it. He did something clever with an arrangement. He's a bass player, arranger, and a developer. I think he put a date on the music sheet that we got, so everyone knew that if we got changes, new version, we would at least know which date to use. So therefore, we would cut down on problems. So laziness wins in the end. You should be lazy. If no one has told you that before, I'm telling you now, you should be lazy. Don't do stuff manually. Because manual deployment, for example, that's boring, error-prone, and therefore it's just stupid. And I don't think any of you are stupid. It also has to be easy to operate, simple to deploy, reread new properties if needed, for example. Make sure that you have good logging. The operations guys, they are your friends, not your enemies. So it should be easy to use this stuff. And we should also make sure that we don't scare our users with bad error messages. So the upper version here is bad. Don't give them an error. Something like this. Sorry, we made a mistake. You did not make a mistake. That's better. Then you don't scare the users. Responsible developer is constantly learning. I said that earlier, and I repeat that. And that's obviously really bad news if you don't like learning new stuff. So what do we learn then? Well, new techniques, new tooling, and we learn about the domain that we're actually working in. And how do we do this? Well, it's not that easy as one could hope for. You actually have to leave your comfort zone. And I'm not sure about the number here. It says that 2% of the population will leave their comfort zone. 98% of the population will never do that. Not sure. But it's very nice to be in the comfort zone. We know what we're doing here. It's scary outside. But outside, that's where we'll learn new stuff, such as this, where Andrei Karavinsky leaves his comfort zone. There was a one-wheeler outside. It's a lot better than I would have done it. But he left his comfort zone and tried to learn how to run a one-wheeler like this. That's good. Maybe learn something new. I hope so. Tools. Well, obviously, we learned a lot of tools, but we know that sexy frameworks, they are just sexy frameworks. We're not fooled by them. you still have to think for yourself. I never found a framework where you can switch off your brain. And if I found it, I would probably not use it because I don't trust it. So use the best tool you currently know, but always be on the lookout for better tooling and use the right tool for the right job. If the only tool you have is a hammer, you will only see, the only problem you will see will be nails. I used to work as an aircraft mechanic. I had a spanner, hope I never used it. But remember, poor craftsman blames the tools, or worse, doesn't even know how shitty they are. So this is a bad tool. Don't use tools like this. It will just create problems. The customer and their domain, yeah, well, that's different for everyone, but we need to get some domain knowledge, and we will do it on the job if nothing else. But divide and conquer, given whatever you know at the moment, you probably learn something. So do it again and again, and then you probably learn something new. Domain is obviously complicated, and it's different from customer to customer. I had to put this one in, guesstimates. How many in here are forced to guess how long time a task will take? 1, 2? Okay, that's nice that there's not more, because as you know, it's complicated, and you tend to underestimate the problem and overestimate your own capacity. So therefore, it's hard and always wrong. So the best answer, this is the way a problem could look like. It looks simple to me, but when you start digging in it, you don't know what you'll find. So the best answer I can give is that either you're done or you actually don't know, because what we are doing hasn't been done before. Hey, it's called development for a reason. So done or don't know, and this will piss off some people, I can assure you, which is really unfortunate. But if they want the truth, then this is the only truth I am aware of. I can say that this is large or small, but not much more. Being responsible does not mean doing as you're told. That's obedience. Dogs do that. We're not dogs. We do what we know is right instead. That's being responsible. More like a cat would do it than a dog. Although I'm not sure cats are that responsible. At least my cats are not. We're ending, almost at the end. Sustainable pace, very important. This is 3 persons, 3 girls. They ran the 100-meter marathon, 100-meter race at the Olympics in London, 2012. I have no idea who won. I have no idea how long time it took, but I'm sure that they couldn't run 200 meters because they were almost dead at 100. And that's not the way we can do development. We want to do something like this instead. We have to plan for marathon because we're going to do this for a long time. This means it won't go fast, but we can do it for a long time. Very, very important. And if you haven't realized it yet, I'm talking about extreme programming. And we have passed basically through all the practices described for extreme programming. So that's actually something I think that is the responsible way to do it at the moment. If I come up with something better, I will do that. I'm also thinking and talking about software craftsmanship with a manifesto like this. Not only working software, but also well-crafted software, very important. Not only responding to change, but also steadily adding value. Not only individuals' interactions, but the community of professionals. And not only customer collaboration, but a productive partnership. That's what we're looking for. So again, no silver bullet. We don't do silver bullets. I'm going to leave you with some action points. Next Saturday, there will be something called Global Day of Code Retreat. I have no idea if if it is arranged or not in Kyiv. Last year, I think there were 2 in Kyiv. They might be full, but if you're able to attend it. If you haven't tried test-driven development, do that. The rules are simple, but it takes a lifetime to master. Very simple rules, very complicated after a while. Try pair programming. And if you don't have a GitHub account, make sure you get one and share some pet project. That's a great way to show people that, hey, I know what I'm doing. Look at the code. And remember, as you sow, you will reap. So when you put the seeds into the ground in a good way, you will get something good back after a while. So what will you do for your future today? Ask yourself that. I'm Thomas. I've been talking about I consider being a responsible developer. Thank you for listening. I'm not sure if we have time for questions. Do we have time for questions? Sorry? 10 minutes for questions. Oh, do we have any questions or do we call it a day? No questions. Oh, one question.
How do you encourage person if this person is not responsible?
Mm-hmm.
He's a good technical guy,
Yes.
good professional, but he does not communicate.
No. So the question is, how do you influence someone that is not, that is a good technical person, but is not very responsible, who doesn't do responsible or behave in a responsible way? I know what doesn't work. You can't, and I hope it's illegal as well, but you can't use force. You can't use violence. So that's one thing we can't do. To be honest, I don't have a good answer to that one. If I had, I would probably travel the world and tell everyone how to do that. I'm working on and off with people who I find very irresponsible, and it's very, very complicated. I don't know how to influence them in some cases. Show them good examples, that's one way. You can only change people, sorry, let me put it like this. The only persons you can change, the only person you can change is yourself. So you can change, and you can show them good examples. But you can't say, you have to change. It doesn't work like that, because if you don't want that, then you will not. Sorry for using you as an example, but I can't, by trying to scream or apply force, do this. I can only change myself, so therefore I can change myself, and I can show people how much easier it gets. Some things are more complicated than others, such as changing the way you build software and deploy software. But try to automate as much as possible. That is the responsible way to do stuff, so therefore I suggest you try to do that. And if you don't get the manager buy-in or something else, well, you know, we dismissed the concept of slavery a long time ago. You're allowed to change job. I would change job. Me being consultant, I probably change customer. They're not worthy me if they don't want to do it in a responsible way. Do we have any other questions? Yeah, over there.
You mentioned the principle to do what is right, but not what people actually asking.
Mm-hmm.
Do what is right,
Yes.
someone else.
Yes.
So the question is, how do you deal with project managers?
So I said that it's the responsible thing to do what is right and not necessarily do as you're told. Well, you have to apply some kind of, so that is kind of the question. How do you deal with managers in this case that tells you to do it like that or do it like that? Well, a lot of things that we are doing is stuff that manager will never ever see. So don't ask for permission. Maybe, if you're forced to it, ask for forgiveness. But that's one of my ground rules. That's where I start. I do stuff. I try not to make people upset. It happens that I do make people upset, but I try not to. And if they are upset because of something, then I will ask for forgiveness rather than ask for permission to do this from the beginning. Because if I ask for permission to do it from the beginning, I will have to motivate this obvious thing to someone who might not even know the difference between for and while, and therefore won't understand the reason me wanting to separate two classes, for example, for there are too many responsibilities in one of them, for example. So I don't ask for permission in that case. I just do it. Obviously, there are cases when people get upset, and well, my track record is such that people are upset sometimes, and I don't really care. No, I don't. I've been around too long to consider the opinion of some managers that don't know anything. A manager who couldn't even implement a FISBUS. If you can't implement a FISBUS, don't talk about programming. If you don't know what a FISBUS is, ask me afterwards. Do we have any other questions? No? Then I think we'll call today. And again, if anyone wants cucumber stickers, I got plenty. Thank you.